Okay, this is on logarithms and logarithmic functions, and then also solving logarithmic equations. First, if you forget everything else about the next week and a half of logarithms, you remember one thing: a logarithm is just an exponent. Okay? If I stop you in the hallway and say, "What's a logarithm?" It's an exponent. A logarithm is just an exponent. And if you remember that, that will help you solve some of these problems. In Algebra 2, you should be able to go from exponential form to logarithmic form to radical form. We have already covered the radical form, so I'm basically going to leave that column blank. Radical form is like if I said square root of x, that's the same as x to the 1/2 power. If I said x to the 2/3 power is the cube root of x squared, but we've already covered that. So we're going to concentrate on exponential form and logarithmic form. In exponential form, they will give you statements like this: 10 squared equals 100. In that statement, the 10 is called the base. The 2 is the exponent. And the 100 is just a number. Okay, so when you write it in logarithmic form, and they're going to abbreviate it with LOG, okay, the log of 100 base, look up here for a minute, base 10 equals 2. The logarithm is just an exponent. Okay? So look how you read that. The log of 100 base 10 equals 2. Okay, so if I give you 1,000 equals 10 cubed. Okay, to write that in logarithmic form, you write the log of 1,000 base 10 equals 3. Okay, now on your calculator. Okay, on the calculator, if you look in the lower left column, far left column, you should find the LOG, and the next one down is LN. LN is natural logarithms. You won't get into that till next year. But the LOG, do the log of 100, the first column, and you should get 2. Log of 100 is 2. If you do the log of 1,000, should get 3. Okay? Now, if you just do, let's say I do the log of 66, and you get a decimal. If I said the log, I need to go the other way. Go the other way. So if you do log of 66, it's understood on the calculator when you use LOG by itself. Log of 66, it's understood to be base 10. Base 10 is called a common logarithm. When you get the decimal, and I'm going to run around this to 5, yeah, and that decimal is the exponent. If you want to go backwards, okay, look right above the LOG on your calculator. You see 10 to the x. Okay, so if we did second function 10 to the x, and then put second function answer, and put in that decimal, and you'll get back to 66. Okay? They are inverses of each other. Okay, now, did you do second function answer? Did you type in that decimal 1.81?
I did second function log, which is 3 then put 1.895.
Did you type that in?
Yeah.
Yes, so you're typing in the rounded value, so the calculator is giving you a rounded value back. So to get the exact value, you have to do second function answer. That puts in the whole decimal. Make sense? Okay. So if you did, yeah. Okay, so okay, so when you do the just LOG on the calculator, it is in base 10. Okay, common logarithms are base 10. And this was you have to use second function answer. You can't just put in that much. Second function answer's got to go in there, and then that'll bring you back to 66. Okay, so if we had one like this, 2 to the third power is 8. Okay, you can go log of 8 base 2 equals 3. But if you type in log of 8 on the calculator, you're not going to get 3 because it's base 10. So try it on your calculator. Type log of 8. You get some other decimal. Okay, so a couple of ways to get this to work. There's what they call a change of base formula. And I think it's critical that you know this. Change of base formula says if it's not base 10, then you do the log of the number divided by the log of the base. The change of base formula is always the log of the number divided by the log of the base. So on your calculator, do the log of 8, and we got to put parentheses around it, divided by the log of the base. Okay, so do log of 8 divided by the log of 2. Okay, then you will get the right answer, 3. Okay. Okay, now there's another way to do that. Okay, but I caution you that on the test, I probably will not necessarily give you the calculator. Okay, so you have to know some of these rules. If you look on your calculator, use the math key. Everybody press the math key. Go down until you find log base. Log base and press enter. Oh. What that does is it allows you to type in this number and this number, and then you get your answer. Okay?
So it's math key and what?
No, not that I know of. Okay? Okay, under the math key, go down. Now, do you have the older black calculator? Okay, you don't have that then. That's why you need to change a base formula. Okay? Okay, so that's a good. And now, some of you that have, if you have just the old TI-84s, if you don't have that, basically what you can do is upgrade your operating system on your calculator, and it will change it to that. Okay? The operating systems, if you have a TI-83 Plus or above, you can download the new operating system free off of the internet. You don't ever have to buy a new calculator. Okay? On the TI-83 Plus. So what we did was, we did the math key. We went down to where it said log base, and we pressed enter, and then it puts in the box for the base and the box for the number. You just fill those in. But there may be a time where you don't have a graphing calculator that has that on there. So that's why it's critical that you know this change of base formula. It's always the log of the number divided by the log of the base. Okay, let's go on with some more examples. Say in exponential form, say they had 8 to the 0 power equals 1. Remember, anything to the 0 power is 1. The only exception is 0 to the 0 power is undefined. So if we go from exponential form to logarithmic form, it'd be the log of 1 base 8 equals 0. Okay? If I give you 2 to the negative 4 power equals, what's that negative exponent do to that number? Moves it down and makes it a positive exponent. So that'd be 1/16. Okay, so you'd have, that's exponential. If we go to logarithmic, we'd have the log of 1/16 base 2 equals negative 4. Okay? If I have 9 to the 1/2 power, 9 to the 1/2 power, anything to the 1/2 power, same as square root. So square root of 9 is 3. So 9 to the 1/2 power is 3. So you'd have the log of 3, the base is 9, equals 1/2. So that's like saying the square root of 9 equals 3. Okay? If you have 10 to the negative 2 power, remember, if it's a negative exponent, that's going to put that number down in the denominator, make it a positive exponent. That'd be like 100. Okay, so that's the log of 100. The base is 10. The exponent is negative 2. Okay, now on your calculator, take the log of a negative 100. Yeah, okay. You won't ever be able to take the logarithm of a negative number, okay? Because on the, it's always going to graph above the x-axis. So if you get an error, that means you're doing something wrong, okay, and working the problem. Okay, now, with that in mind, they will say, evaluate. And I always say, if you're stuck in exponential form, go to logarithmic form. If you're stuck in logarithmic form, go to exponential form. Go back and forth. On these problems, they will say like the log of 125 base 5. When I write that in my notebook or something, I would not just write it that way. I would say set that equal to an unknown. Set that equal to x. You're in logarithmic form, go to exponential. What's the base? 5. The exponent? A logarithm is just an exponent. So it's 5 to the x power equals 125. And then you got to get the bases the same. And I'm asking you to do it this way on the homework rather than, I don't want you to just type this in on the calculator and type this in on the calculator. No, I want you to know what you're doing. Okay? So this is 5 to the x power equals 5 to the 3rd power. Bases are the same, so set the exponents equal. So x equals 3. Now you can check it on your calculator if you want to. You can say, use the log base thing on your calculator to check it, but I want you to work it this way. Okay, second example. Say you have log of 3 base 27. Okay, again, the author's going to write it like that. I want you to set it equal to x. You're in logarithmic form, go to exponential. 27 to the x power equals 3. Get the bases the same. You always want to go to the smaller base. 27, I can get that in base 3. 27 is 3 to the 3rd, and raise that to the x. When you raise a power to a power, you multiply them, and this would be like 3 to the 1st. Bases are the same, set the exponents equal. Divide by 3, should get x equals 1/3. Okay, questions on that one?
Okay.
27 would be 3 cubed. Raise a power to a power would be 3 to the 3x equals 3 to the first. Set the exponents equal. Okay. Okay, another example. Log of 64 base 2, and I'm going to set this one equal to y. The base is the 2. The exponent, remember a logarithm is just an exponent. And go to the smaller base. 64 is 2 to what power? 2 times 2 would be 4, times 2 would be 8, times 2 would be 16, times 2 would be 32. So yeah, 2 to the 6th. The bases are the same, set the exponents equal. So y equals 6. Okay? Okay on that one? Okay, now they will give you problems like this. Solve logarithmic equations. And a little note in there, check for extraneous roots or solutions. Okay, and basically that means you can't take the log of a negative number. So you basically on these you got to at least check your answer. Okay. So example. Say they have the log of x squared base 4. So when you read that, you read it log of x squared base 4 equals the log of 4x minus 3 base 4. If those two bases are the same, they're both base 4, then that means this part has to equal this part. So set them equal. That's just in the problem. That's part of the problem. So then you got to set x squared equal to 4x minus 3. Now you've got a quadratic. Get it in standard form equal to 0. Subtract the 4x. Add the 3. So we're going to subtract 4x on both sides. Add the 3 on both sides. And you always want to try and get your squared term positive. It's positive on the left, so leave it alone. So you have this quadratic. Is that factorable?
Yeah.
Into, there's nothing in common. 3 and 1? 3 and 1? What about the signs? This tells you they're alike, this tells you they're both negative. So you get x minus 3 equals 0, so x equals 3, and x equals 1, okay? And they should both check, okay? Because you won't get a negative value up there if you put 3 in or if you put 1 in, okay? Last example. So you get the log of x squared minus 15 base 3 equals the log of 2x base 3. Okay, if those bases are the same, if these bases are the same, and you've got an equal sign in between, then that means this part has to equal this part. So x squared minus 15 has to equal 2x. It's a squared quadratic. Get it in standard form equal to 0, so subtract 2x. And if you can do that by sight, do it by sight. Standard form equal to 0. Is it factorable? Into x minus 5 and x plus 3. So you get x equals, if you set that equal to 0, x equals 5 and x equals negative 3. If you put that in, 5 squared would be 25, minus 15 would be 10, that'd be a positive. 2 times 5 would be 10, that'd be a positive. Put negative 3 in. Negative 3 squared would be 9, minus 15. Nope, that's going to get, so this one you got to reject. You can't end up taking the log of a negative number. So your only answer would be 5. Okay? Okay, questions on any of that?
So, we don't have any, like, where the digits are not the same?
Not yet.
Okay.
Not yet. Shouldn't. Okay? Okay.